Wagmode Pratik, number 51. Hello. Wagmode, are you listening? Or this time also taking lunch? Pratyush Wagmode. Hello. I'm asking to you, Wagmode Pratyush.
Yes, sir.
Have you submitted the assignment first? And what about the notebook screenshot? I told to make notebook on the send the screenshot of all the notebook chapters.
Sir, I submitted only assignments, sir.
And what about notebook screenshots? Have you made a notebook?
Yes, sir. Today I will submit, sir.
Have you written all the things, all the notes what we taken in the class?
Sir, last lecture not, but
Why? What is problem last lecture? Today itself, I want all the note chapter 1, chapter 2 complete photos of that, screenshot of the notebook. Today up to 12. I want all the things. Is it clear, Wagmode? Okay, how many of not submitted assignment? I put the message yesterday. What is problem? I should not waste time every time to ask you. Actually, I will not allow for the class when the deadline is not followed by the students. I think roll number 6 onwards, 5 onwards they have submitted. What about roll number 1, 2, 3, 4? What is problem? Shivani Atkale.
Yes, sir.
Have you submitted assignment?
No.
Then what is problem? Huh? Chalo, I will remove the students. Those are not submitted assignment from the class. Chalo. Leave the class. Those are not submitted assignment immediately. Shivani, Ankita, Shruti Bhinge.
सबमिट
केलेली आहे. कधी केली?
काल.
ओके, म्हणजे डेडलाईन दिल्यानंतर फॉलो करायचं का विचारल्यानंतर सरांनी? One chapter will be finished. We have given and we discussed that 1 week will be there to submit the assignment. More than 15 days are over by finishing the chapter first, and only 3 questions are there in that. And no one should mail me or put on the WhatsApp post. What is the link given? On that link only you have to upload PDF file only of 10 MB. Is it clear? Chalo, we'll see that who has submitted, who has not submitted. I will share the screen. See the situation. What is I actually 3 questions to write 3 questions. You don't have the time. Roll number 1 to 5. No one is submitted. Roll number 1, 2, 3, 4.
सर, मी सबमिट केली कालच.
Where is your number?
3.
Roll number 3. It is there. Roll number 3 is there. 5 is there. 4. What is 4? 4 also there. 2, 9. Just put number, roll number. Huh? Don't put A, all this thing. We have the separate link for that. Okay, 3, 4, 5, 6 submitted. 7, 8 submitted. 9 submitted. 10, 11, 12. Who is 12? Roll number 12. So hereafter, if I'll not get assignment, I'll put the absent for my class. They were present in the class. As per this students will be present for my class. Okay, is it okay? And nobody is sending the screenshot of the notebook, but we follow the protocol. Only through 2-3 students are sending that. Chalo, what is the last lecture? We'll repeat. Fast. 10 minutes are went in this process only. Fast. What is in last lecture?
Input output port.
Yes. So port 1 we are discussing. In port is one is
Yes.
a bidirectional port, and how to make input and how to make output. What is condition? How to make certain port as an input? How to configure?
To make a certain port as input,
Mhm.
give a high, that is 111. To
High level
make
signal
a
on that port.
high level signal, and to make the certain port output port, give a low level signal 000.
Correct. This thing is were discussed. And to make as input, why we are not writing the 0?
When we give the 0,
Hmm.
that time q bar become 1 and output is going to ground.
Yes, very correct. In this condition itself, if you put the if you write here 0 to make as input, if this is 0, Q bar will be 1, and which make the just MOSFET M1 on condition. If it is on, all the data what is going to the ground side, it is not coming to the read line pin. Okay, so that very important, we have to write 1 on the internal bus to make the or to read the port as an input, or to make port as an input. Clear? And we discuss about this writing 0 and making the port as output, this condition. Correct, na?
Yes, sir.
Okay. Easy hai? You understood, I think. Chalo. Then we'll go for the second condition in that port as a output and writing high on this pin. Means this pin becomes high level. We're writing the sending one to this port, any port pin, 1.1, 1.0, 1.2, anything. Okay. And next point, C condition under this port 1 as a output and writing high level signal. Write 1 to the port. Means value on this port becomes high level signal. So diagram will be same for all the port 1 port, what is seen for the read write condition input output. Okay. So just we write the condition for that. Diagram will be same. You can say write the diagram what you are taken in the for the output port writing 0 A. So you can say that in port above figure A, if you write here 1, what happens? Let us see. Okay. So to make that port 1, we have to write here high level signal on that. So once it is high level signal, D equal to 1, Q bar is equal to 1. Okay. So as Q, sorry, not Q bar, Q is equal to 1, means Q bar will be 0. As Q bar is 0, this MOSFET M1 will be off. This MOSFET off means what? What is VCC is coming here? Is directly goes to the output pin, that is P1.x. So this P1. Value of this P1.x is equal to VCC. VCC means high level signal. Simple thing is there. And that time we are not reading anything on that pin. We are writing to that pin. Clear? Have you understood? Hello.
Yes, sir.
So write down in the C point below that to write 1 on the output pin 1.x. To write 1 means what? High level signal. To write 1 or high level signal on output port or output pin 1.x p1.x. p1.x. First condition काय करायचं आहे? Internal bus, right? Internal bus is equal to 1. Internal bus, CPU bus is equal to 1, which makes Q equal to 1. Write 1 to internal CPU bus, which makes Q equal to 1 and Q bar 0. Q bar 0. Next line. As Q bar is 0, the MOSFET M1 off becomes off. We can write shortcut also. CPU is equal to 1, D equal to 1. D equal to 1 means Q equal to 1. Q equal to 1 means Q bar 0. Q bar 0 means M1 off. M1 off means this output VCC directly load condition goes to the output pin 1.x. So 1 point after that P1.x is equal to VCC means high level signal. Means we're writing high. High means one signal on that pin. Written over. Is it over? 2 lines only explanation of that. Hello.
Yes, sir.
And what is this load L1 called as? What is this load? So this is called as a internal pull-up resistors. Okay, except port 0, all port has internal resistors. But in case of port 0, we have next port, we have to connect the external port. But internally for P1, port 1, port 2, port 3, we have the internal resistors. Okay, and this is the driver. If you see the architecture diagram, it is written. And what is this? The flip-flop act as what? What is this is called as what? If you see the diagram of architecture diagram, 8051 latch. Okay, so we have the port 0, port 1 latch. So D flip-flop act as a latch. So like this, we have 8 flip-flops internally connected to the each port pin. 1 point here X is written. So P1.0, P1.1, P1.2 like internally. And like this, we are getting the 8 pins as output. Done? Clear? Is it understood, everyone? Hello? Hello? Mahesh, you have to reply. Other students also.
Yes,
Or, should I go to next point?
Yes.
Chalo. Then diagram will be same only. Condition is what? The input port will be there and reading high level signal from this pin. The pin becomes high level now, and I want to read this signal high level from this port pin. How to read? What is condition? And we know that to make the input port, we're writing always high level signal on the internal bus by using condition. This instruction move P1 comma 0FF. We've seen this also. So this is as this is writing high level signal, D becomes 1. As D becomes 1, Q 1, Q bar 0. Q bar 0 means this FET is off. Okay, as FET is off, what is signal is present high level reading directly to the read pin. Okay, the read pin will read the high level signal. Same way what we've seen the first point to make input port as a input that time. If the 0 is written here, we'll read the same signal here. 0 signal on the read pin. Second is that only. See, low level signal reading on the port pin. At this pin, this is 0. 0 means what? I'm reading the then same signal. And to make this input, we're writing 1 on the high pin, D1, Q1, Q will be 1, Q bar 0. Q bar 0 means this fate is off. Fate off means what? What is signal is present at pin 1.x 0. I'm reading directly by 3D pin. So once we understand input output port, how to make, things are very easy to understand. Chalo, next write down port 0. Write down port 0. Draw this diagram. Make it fast, port 0, and write down this diagram. So if you see that port 1 diagram and the port 0, we have changes here. Otherwise, things are same for this and this part. Correct? What is changes here I am observing? This part is not there. Mux, this is called as mux. And here we have the inverter and the address data bus and control register. This is M1, M2, same way. So why this part is included? Kon सांगू शकते मला? Why this part is included here? Kon सांगते? Hello. Have you understood this? Janvi Devdekar, why you are late?
सर मला नेटवर्क मिळत नव्हतं मी ऍड करत होते मगापासून पण आउट होत होते सारखे.
Why you problem with you only? Other students are
कार्डचा
joining
प्रॉब्लेम
later. Huh?
सर कार्डचा प्रॉब्लेम मी घरून येत होते ऍक्च्युअली गाडीवर होते.
You should, if you are coming to the college, you should enter at right time, na madam, before 9:30 or 10, before 10.
I was trying.
Okay. Take it fast. Then draw this diagram. Deshmukh, Mahesh, what is the change in the diagram? Port 0 and the port 1. Rather to change, why this part is included here? Kon सांगते? Deshmukh Vaishnavi.
Yes, sir.
Why this thing is included here? If you observe the pin diagram, you will get the hint of that. Okay, so port 0 act as what? Port 0 act as IO port. Correct, na?
Input output port.
As well as?
Lower address.
Yes, it acts as lower address and the data bus 80 to 87. Okay, if directly this will be port as output only, this thing is not required here. So we have to make that port as a input output as well as a data bus lower and an address bus lower. That's why this extra circuit is added in that, and that will help to make that as input, the port act as an input output or the data address. Okay, clear now? That's why it is included. Diagram is over. This diagram is over.
No, sir.
Make it fast. Port 1, port 3 will be same. Only port 2 and port 0 have the changes in the diagram. And every port we have to look for as input, how to make input and how to make output. Write 0, write 1 on that port. Or read 1 or read 0 from that port. But thing is that I think you are not reading the notebook. Once it is written, you have to read it. And as I said that we are not like Swami Vivekananda, as we are understanding all the things once we read it. Done? Over diagram is over. Is it over?
Yes, sir. Over.
Yes. Draw it fast. We should not waste too much time in the drawing the diagrams. Okay. So this is the internal diagram for the port 0. And if you observe here, internally we don't have the pull-up resistors. As we see in the port 1, we have the internal pull-up resistor. This load act as a internal pull-up. If this will not be there, what happens? We have to see in the port 0. So port 0 doesn't have it. So we need to connect externally here from this to this pin outside. Okay. So again, we have the two conditions to make this port 0 as an input and to make port as a output. So to make this port as a input, what is condition? We have to write internally to the bus d equal to 1 initially. This is not important. Okay. At the same time, the control signal, as we have to make this data and read this control signal will be always 0. Okay. Next diagram is there. We'll see that. To use port as input as written here, CS signal is 0 and the right 1 on the pin number. This internal bus pin is 1. Okay, as this pin is 1, D equal to 1. D equal to 1 means Q. Q is equal to 1 high level. As Q is 1, please draw it Q bar here. It is not written here, but it is Q bar. As Q bar is equal to this is 1, Q bar will be 0. 0 means what? It is not connected here. This FET will be off. Okay. So this FET is off. M2 is off. At the same time, this M1 flip-flop for M1 MOSFET also will be off. Why? Because this is high level signal, but CS is 0. So this is AND gate. AND gate input is 1, 0, 1 is 1. So either one input is 0, output will be 0. At 0 means this is also off. At both the switches FETs of M1, M2. That is meaning that what is port is available, we can read the data from the port by read pin. This is condition. Now we have taken this part here. Same thing we discussed Q1, Q bar 0, FET to off because of this Q bar is 0. And the same time CS signal 0, M1 is off. So what is available signal? I am read by the read pin. We'll see the next diagram is here. Okay, same thing. CS is 0. I just written the pin by using that. So D, as I'm writing D equal to 1 on the port pin. So D equal to 1 means Q bar 1, Q is 1, Q bar 0. Q bar 0 means this signal is not connected to the FET. So that C is 0, this M2 is off. M2 off means what? By default, this ground pin is not connected. This signal will not come to the ground level. So what is signal available on this port 0? Read by the read pin directly here. Okay, how this M1 is off? As CS is 0, irrespective of this address data, either 1 or 0. Output signal of this AND gate will be 0. This 0 means M1 also off. Clear? Understood? Hello?
Yes, sir.
Write down fast below that. What you understood here, you can write easily. Notice what? To make as input port, write 1 on the internal bus. Means D equal to 1. Always try to remember to make input. So as a D equal to 1, Q is equal to 1 and the Q bar 0. As Q bar 0, M2 is off. And as CS signal is 0, M1 also becomes off. So what is data is available? It is read by the read pin in the controller. So I'm reading that. Whether diagram is very clear? Is it visible to all? Hello?
Yes, sir.
Because Trupti's owner has put some message, his is not clear. Trupti be in the proper range. Done, taken to make input port. Hello? Yes, sir. Okay. This is over. Simple explanation I've written for the input condition now. We'll go for the next part. Write down B. Don't have the diagram now. Diagram will be same. Just will write the explanation of that. Port 0 as a output port. And writing 0 on that. Condition is what? Writing 0 will be same as making output port. Write B condition, port 0, B condition, port 0 as a output port and writing 0 to this pin. Now this pin is output pin, and what is data available on that pin? Will be 0, writing 0 on that. That's why. Okay, so as we know that to make output port, we have to writing always from internal data bus. I'm sending 0 signal. So internal bus CPU bus is equal to 0, means D will be 0. As a D flip-flop 0, output Q will be 0. Same time, the Q bar will be high. So as Q bar is high, this pin is connected to this pin directly here. Okay, and CS will be 0, same time. So as this pin is connected here, M2 becomes on. As M2 is on, what is signal is available on this port goes to the ground level signal. And this port pin is connected to the ground. That's why data available on that pin will be 0 or the low level signal. Means we're writing 0 on the port P0.x. Okay. The same time, irrespective of this, M2 will be off as CS bar signal is going to be 0. Clear? Is it clear? Hello? Have you understood this? Port 0 output and how to write 0 on that?
No, sir. एकदा repeat करा.
Okay. So what is our condition to make the port 0 as output? What we are taking the condition? Sending the 0 on the port pin. How we are sending? By using the internal CPU bus. So on this pin, I am sending 0. At this pin 0, D will be 0. Okay. D0 means what? Q will be 0. As Q is 0, Q will be high. High means this is active high signal. The switch is going to be connected from this pin to the here. As switch is coming here, the Q bar directly connected to the M2 MOSFET. And it will make the, as gate is on, high level signal, this MOSFET is going to be on. Up till now clear? So as M2 will be on, what happens? This is short circuited, goes to the ground level signal. Means the port pin is equal to grounded. What is signal available on this port? Becomes ground. Ground means what? We know the 0 signal or the low level signal. So the port we are making as output and I am writing 0 on that signal. 0 means low level signal on that. The same time, irrespective of this M2 is on or off, doesn't matter. If it will be on, why it will be grounded. It is off, doesn't matter. And why it is off? Because CS signal is going to be 0. That's why it is by default off. Okay, clear? Hello? Write down the condition for discuss this part. Hello. I have taken this operation of this in short. Things are written here also, but we should understand. Written? Hello. Mahesh, done
Yes,
this?
Done.
Devdikar, Sonar, Trupti, Deshmukh, Atkale,
Yes, sir.
done?
Yes, sir.
Simple, you have to write to make output port. Internal bus becomes 0. D, that's why I'll make D0, Q0, Q bar 1. As Q bar 1, this MOSFET is get connected to the Q bar is equal to 1. That's why it is on signal. This, as it is on means what? Understand here. This port pin directly connected to the ground here. And any signal is connected to the ground means what? The signal level available will be 0 on that. That becomes writing 0 on that. Similar case. Let's see the second case. Writing high level signal. Port has output and writing high level signal on that. Okay. So diagram will be same only. That's diagram. So I'll consider here. So but condition is what? Writing 0 means we are sending the high level signal on that because we have to write high level on that. So to use port as input, the CS signal will be 0. Okay, as CS 0, this high level signal is written on the internal bus. And as CS is 0, that M2 signal will be off. No issue in that. And D is equal to 1, M1 also off to the control signals. Okay. And that's why the signal is floating. Let's see how it will be there. Okay. So I'll take this signal in the here. So we'll understand better way. That is available, visible. Is it visible to all now? Hello. Diagram is visible. Or let me
Yes,
see.
sir.
I can notation. Writing tool is not available, I think, here. Okay, it is there now. Okay, so to make the port 0 as output and writing 1. So what is condition? We have to write the signal on this internal bus is equal to 1. So D equal to will be 1. But why it is going? I want it should be remain on that pin. I'll use the text. Let's go in the paint. Will easy for us. Okay. So I'm writing to make as output port and writing 1. This will be 1. Okay. As the D equal to 1, the Q level signal, Q is equal to 1, which will make Q bar 0. As Q bar is 0, this M2 will be, you tell M2 will be on or off?
Off.
It will be off. Correct. The same time, the CS signal, this CS will be 0. Control signal will be 0. As CS will be 0. What about M2? Sorry, M1.
Off.
So M1 also off. Okay. So this M1, M2 off. What about this pin condition? this pin will be floating. Correct, na? Now this pin will act as what? Floating. Neither it is connected to the ground, neither it is connected to the VCC. Correct, na? Hello. So write this 0 on the signal, make output port and the rating 1. I'm looking for this condition. To write 1, the internal bus D equal to 1, Q1, which makes Q1. And the Q bar will be 0. As Q bar 0, M2 is off, and the C is 0, M1 also off. That's why. What is the nature of this pin condition? Status of pin? It is floating. Okay. As this is pin floating, as M1 is not either it is connected to the VCC, and either it is connected to the ground signal. Okay. This pin becomes floating. Okay. So that we need to add the external resistors to be connected here. Okay. So this external resistor will be connected from the VCC pin to the directly output pin, so that this pin becomes connected to the VCC. So the data available on this port pin P0.x is equal to what now? VCC. As this becomes VCC means what? The high level signal is present, which makes it is a 1. Means high level data will be available on the port pin. Clear? Is it clear now? So why we need to connect the normally question is asking in the external exam, oral exam, or the theory exam also. Why we need to connect the external pull-up resistors in case of the port 0 only? Because when we are making the port as output and we're writing means what? Simple, I'm connecting LED here and I'm making LED on off. To make LED on, I'm writing high level. To make LED off, I'm writing 0 level signal on that. Okay. So when I'm writing, making port as output and writing 1, that time internally doesn't have the pull-up resistors. That's why the port pin, this pin, all port pins, P0.1, 2, 3, 4, 5 to 7 are floating conditions. Floating why? Because M1 is off, M2 also off. Okay. To make that either it is VCC or ground, I'm using external pull-up resistors to here from VCC to the port pin. That's why the signal VCC directly come from this load pull-up resistors to the here. So because of that, the voltage level available on this port will be VCC, means high level signal. Means I'm writing 1 on that. Clear now? Is it clear? Hello. Kallega Saravanna, Mahesh.
Yes, sir.
Why we need the pull-up resistors externally in case of port 0? The question will be there, either for 4 marks or for oral exam or MCQ. Because when it will not be there, this port pin will be floating condition. Let's come back to our discussion. We can see here. When this were making condition like this, see a signal 0 and high level signal on internal bus, M2, M1 will be off. And that will make the output pin P1.x. This pin is a floating condition. So as it is floating, we need to connect the external pull-up resistors in parallel to the M1. Means first FET here in parallel to the M1 port as act as a load. Okay. So that the signal will be available to the port pin directly. External produce parallel to the M1 FET or the MOSFET. So it will provide the high level signal on the output pin. And how to connect this? Here is that condition. So it is the diagram for internal integer 51 port 0 is 0.0 like this. And we need to connect the externally from VCC pin to the port pin. All the 10 kilo ohm pull-up resistors, and then only data available on this port pin 1, 1, 1, 1. And I'm writing 1 to this port. Clear? Is it clear? Hello. कळले सर्वांना? देशमुख, महेश, वैष्णवी, अटकळे.
Yes, sir.
चलो, write down this part fast, everyone. and you need to draw this diagram. First draw this diagram and then I will tell that part what to write. So finish diagram fast, everyone. So we'll write for this also here. External pull-up resistor. Done. Diagram is over. This second time you are drawing the diagram, so don't look for each and every part. And this is last reminder, everybody must upload the assignment today itself before next lecture. So I will not take the students for that lecture and I'll put absenteeism for today's lecturers. Okay, diagram is over. Done. Diagram draw करून झालंय का? Hello. This diagram is over. Hello. Mahesh.
Nice, sir.
I should not take the specific name every time. I'm asking to your class means as a class representative, you should reply it.
Done, sir.
Okay. Then we have to write about this. Write on that part. How to make the port output and writing one on that. Shortly you can write, no issue. This thing I have written statement wise. we can write the condition, what you write in the diagram, this diagram. So I'll paste this diagram also here. Both diagrams are correct. This part, shortly we write down. To make port 0 as output, CS signal 0, internal bus signal high level, which makes Q1 Q1 is equal to high, Q0 low. So as CS is 0, M2 by default off, and as Q1 is 1, Q bar will 0, that will make the M2 is off. Okay, and that's why the port pin will be floating. And to available the signal high level on that, we need to connect the external pull-up resistors from which is to the port pin parallel to the M1. This condition, write down fast. And what we written shortly in the diagram, we should be able to explain it. And how we should be able to explain it, you should understand proper way. Just we have to make the conclusion. If D will be 0, D will be 1, what is the effect on that? Over? Done?
Yes.
Huh. Next condition is, as we said that we are making the input port, the port was 0 as the input output. That is over now. Now I have to use the port as the address of the data bus. How to make that? Conditions are given here. Right on last C part in that. Port 0 as the address of the data bus. And when we have to make address data bus, the CS signal will be 1. When making output input, by default it will be 0. Done? Okay. So to make the port as either input, so it is data or address. Data means same way, writing 0, writing 1 on the port pin. That conditions. Okay. So for that, first thing is to make address data, the CS signal will be 1 by default. And for writing for address or the data is equal to 0, means I'm writing data 0 on the port pin. Okay. So what happens that time? See, let us see that. So as the control signal is 1 and AD signal A bar D bar 0, means I'm using the data pin 0. The upper MOSFET will be off. If you see here, this MOSFET will be off irrespective of this signal. Huh? So I'm making CS is 1 and AD signal 0. As this is 0 now, this is 1. Sorry, this is 0, this is 1. CS is 1. By default, M1 will be off. Okay, but I'm writing the data signal is 0 here. So 0 is coming here means what? Q will be 0 and the Q1 bar high. So at the signal high, this is connected to the MOSFET 2 gate and the MOSFET 2 will be on. So MOSFET 2 on means what? By default, this port pin connected to the 0 means signal available on the data, 0 available on the port 0 pin. Same thing is written here. Okay, so lower FET is on as Q bar is on. So which will connect to the ground level and the low level signal is available on the pin. And when I'm writing the 1 on that condition, same control signal high and AD signal is 1. So upper FET is on by default. Okay, and the lower FET will be off by default. Why? D is equal to 1, Q is 1, Q bar is 0 in condition that as one, all the signal 1 here. Okay, the address data is equal to 1, CS 1. So by default, this MOSFET is 1. But in this case, it will be 0. Why? As a D is equal to on a writing high level signal, D will be 1, Q is 1, Q bar is 0. As Q bar is 0 means the M2 signal is off. And what is signal is coming here port pin directly VCC, as this is on here. So that port pin will be high level signal. Same condition is written here. CS and the AD signal 1, upper FET is on and lower FET will be off because of the Q bar is 0 now. So what is signal coming on the port pin is equal to VCC. But here we don't require the pull-up resistors now because CS is 1, it does not require to connect the external pull-up resistors here. Is it clear? Hello?
Yes, sir.
Okay. Have you taken this? So more clear you can write here, FET on means Q bar signal is on here, that's why. And in this case also lower FET is off means M1, M2 is off, as Q bar signal is going to be 0. Take this. Please someone look it. Actually, I'm trying to writing. I've seen how to write on that. This time we can tick it. Text, mouse.
तर तिथं
Drawing का?
M2 ऑन पाहिजे ना
कुठे?
ते due to control equals to 1 AD1 upper FET
This one.
खाली black
Okay.
line
This.
हा तिथं M2 ऑन पाहिजे होतं ना
Yes. I'll use the mouse. M2 in this case.
हा म्हणजे पिन ऑन होण्यासाठी
कुठली pin? You're seeing for the condition this address and the data 1.
Okay. Now I get
In
it.
address and the data 1, CS also 1 means FET 1 is on.
Okay, sir. Okay.
Clear?
I thought that the both conditions are.
both condition नाही, एक condition फक्त. कळलंय का नक्की? पेपर सेक्शन करू. Hello. Done everyone this? Mahesh?
No, sir.
No or yes? These two things are different. This is two conditions. Writing data 0, making 0 and data 1. That's why I make the color also.
And done, sir.
And why will tell me why would no doesn't require the pull-up registers, external pull-up registers in this case when you use the data or address bus? कोण सांगते? कोणाला कळले बघूया आपण. In case of address or data bus to be used as a port 0, we does not require the external pull-up registers. Why? Condition. This is important. In case of address and data, CS signal is 1. Okay. So CS signal 1 means what? On this port here, the AND gate input, CS by default on. As this is on, and in case of writing data 0, this is 0. So 0, this signal 0, this is 1. By default, this will be off. But at the same time, writing D0 means what? Here I am writing 0, D equal to 0. That will be Q bar 1. Q bar 1 means for M2 on. M2 on means this pin go to the ground level signal, means low level signal. And in case of writing data high, data is equal to 1. Means data is 1, CS also 1. 1 means fate M1 is off, on. And fate M2 will be off. As the D is 1, Q bar will be 0. So both the case, either fate M1 or M2 is on. That's why this port pin either is connected to the ground or VCC. In case of writing data or data or the address bus. Okay, that's why it does not require here pull-up registers. Clear now?
Yes.
This thing is required to understand. External questions asking and inter questions asking like this only. You should understand internal diagrams of that. Then we have the port 2 and I think 10.59. Other ports working of the port 2, port 3, very same as we have seen for port 0 also. Just writing internal bus 1 low signal, which will make the higher low. We have to see that part. Let us see, we'll see in the next part. Time is up, I think. Correct, na?
Yes.
एवढं डायग्राम बघायचं आहे, port 2 चं डायग्राम बघायचं. Initially, we are a little bit wasting our time, 5-10 minutes. 1 hour for one port, then we will require more lectures to conduct. Because our syllabus chapter 2 is a little bit vast, it requires more lectures. 10-15 lectures are required for this. ठीक है, थांबूया आपण. We'll stop it here. Huh? Waiting room students not allowed. After 10 minutes, I am not taking anybody inside to the class. This is as per the requirement from the meeting. I understood that. So roll number 1 is present. Fast attendance there. Roll number 1 is there.
Yes, sir.
2 absent. 3 fast.
3 present.
4
3
is there. Huh? 4 absent. 5 6
Present, sir.
7
present.
8
Present,
9
Present.
10
Present, sir.
11
Present, sir.
12
Present, sir.
13
Present, sir.
14
Present, sir.
15 16 15 absent 1 5 16 absent 17
Present, sir.
18
Present, sir.
19
Present, sir.
20
Present, sir.
21 21 absent 21 22
Present, sir.
23
Present, sir.
24 absent 25
Present, sir.
27 6 sorry 26 absent 27
Yes, sir. 27.
okay 28 28 absent 29
Present, sir.
30
Present, sir.
31
Present, sir.
32 33
Present, sir. Yes, sir. 33 present.
yes 34 34 absent 35 absent 36
Present, sir.
37
Present.
38 38 absent 39 absent
Present, sir. 39 present.
fast 40 40 absent present 40 40 is there
Present, sir.
okay 41
Yes, sir.
42
Yes, sir.
43
Yes, sir.
44 absent 45
Present, sir.
46
Present,
7
sir.
8
Present, sir.
49
48 present.
49 absent 50 51 52 ओंकार,
Present, sir. Present, sir.
yes. ठीक. You can go for next lecture.
Sir,
हा
28 आहे sir present.
28 आहे. मग नंबर दिले कसं काय कॉल केल्यानंतर आय कॉल्ड द नंबर शुड आय गिव्ह द प्रेझेंट.
Sir, तेव्हा लक्ष नव्हतं सर.
मोबाईल ठेवून गेलता कुठेतरी मग हे जमिनी आहे.
नाही पकडूनच बसलं मोबाईल तरी नंबर गेलेला कळाला sir.
28 चा स्क्रीनशॉट मला पाठव लगेच मार्क करतो प्रेझेंट.
कुठलं?
Today's lecture, send me screenshot.
हो.
Putting my roll number on that. Who else?
Sir, 47.
47. ठीक. Who else?
48 sir.
48 is there, present. चलो. Upset numbers 2, 4, 15, 16, 21, 26, 34, 35, 38, 44, 49, 50 and 51. वाघमोडे प्रत्युष कुठे गेला मध्येच. चलो ठीक.